So that's a whole circuit. Will generate electricity, comes out as high voltage, through the transformer, low voltage, through your house and your appliances, down to the ground and back to the generator. So that's the circuit. Well, the thing about electricity is it's a cheater. It doesn't want to have to go through the transformer, the low voltage wires, your appliances, and then down. It would much rather go from the high voltage all the way down to the ground right away, right? It'll take a shortcut or a short circuit, and that's what it'll do. What does that mean to us? We can be safe if we don't become that short circuit. We don't want to become that shortcut to ground. So, two ways that we can stay safe: isolate or insulate. You're isolated because you're far away from this. We're actually going to energize this to 12,000 volts. So, we can't be isolated from it, or we wouldn't be able to effectively do this presentation. So we insulate. That's what our gloves are. We use rubber gloves, which are a very good insulator. They keep the electricity from getting to us, and it allows us to work on it. So, enough of that stuff. Let's show you a little bit, right? So here's a guy, he's got a pole. Maybe he's trimming a tree, cleaning a pool, something like that. And if he doesn't pay attention and he gets too close to these lines, now, if you look close, he doesn't even need to touch the lines. He just gets close to them. See what I said about electricity is always trying to go down to the ground. If you look at his feet, the electricity will flow right down that pole, right through his body and down to the ground. So our bodies happen to be a very good conductor of electricity. They'll carry electricity real well. That's not good for us. That's very bad. So if we run into a situation like this, it's usually going to end bad for us. Now a tree, quite often these trees will grow up into our power lines. You think it's safe to touch that tree? Is a tree a good conductor or is it a good insulator? Oh, let's find out. Let's take a look. So this is a piece of a tree that we just grabbed from back over there, a bush, and it'll carry electricity just like a piece of wire will. So, lesson there. If you see a tree that's growing up in the power lines, don't touch it, right? Don't get near it. Call us, we'll come out, we'll trim it, we'll make it safe. We don't charge for that. We want everybody to be safe. So, now here's another piece of wood. You might think that that's a good conductor, right? Another piece of wood, that's a real piece. Tree, let's take a look. Nothing.
Let's see.
No, it's energized. So what's the difference? That's exactly it, right? That's a dead piece of wood, which means it's very dry, okay? A dry wood, like this wood down here or that wood, won't carry electricity very good. It's actually a pretty good insulator. We don't want to rely on that to keep us safe, but just the same, it does work very good as an insulator. So, now, next question is, if a wire's down, can you tell if it's energized or not? I know if you watch the movies, right, Hollywood, whenever a wire comes down, boy, there's sparks coming off it, and flames and arcs and all kinds of stuff, makes all kinds of noise, jumps around. Well, in truth, it may do that, but it might not. There's nothing, it might sit there quiet as can be, just waiting for someone to come up and touch it, like this guy. If he touches his car or the wire, bad news. There's that electric arc from his body down to the ground, or through his body down to the ground. Now that car is energized, the same as the wire. So now here's the question. If you're in that car, do you think it's safe? Inside the car. So we can't quite fit the guy inside the car, but just sitting him on top is the next best thing. And we don't have any arcs, right? The car's still energized.
Rubber tires.
Rubber tires, not necessarily, because depending on the voltage, it'll jump right past that. Or most tires nowadays, steel belted radials and stuff, there's steel inside the tire. The best way to explain this is right here with this guy. Right? Not necessarily a bald eagle, but we've all seen birds land on wires, right? And they'll land there for a little while and they'll stay and then they'll fly away and they're fine. Well, they don't have special feet. Their talons, their claws are basically the same as our hands. Their bodies are nothing special. They're built kind of like us. So how can they do that? There's no path for that electricity to go through their body. Now remember, this guy was touching the wire in the ground, right? Remember what I said, electricity's trying to go down to the ground. Can it go down to the ground through this bird? No. There's no path for that electricity to go. It's the same if you're inside a car. You're actually energized to the same voltage as that wire, but there's no path for that electricity to go through your body and go anywhere. It's just going to stay in your body, basically. So the bad news would be if you step out of the car, there's that path to ground, right? Or if somebody else was to come up and touch that car, there's that path. But as long as you stay in the car, effectively, you're just like a bird on a wire. I also have a picture here. This is one of our guys working, and he's working on 230,000 volt lines, but he's working on it from a helicopter. It's energized, but the fact that he's only touching one wire and nothing else keeps him safe. So there's other precautions. He has a special suit on, but effectively it's the same thing. So best thing to do, if you see a wire down, don't touch it, stay away from it. The further the better, and call us.